Okay, this is the last video and probably the shortest on the physical properties of a simple wave. We've looked at frequency, period, wavelength, speed of sound. We've looked at amplitude, and in this video we're going to look at phase. And yes, that's there for a purpose. We'll get there in a second. When we're looking at the waveform, here's a waveform. The main idea with phase is to tell the difference between this wave and, let's say, this wave. They have the same frequency, they have the same amplitude. Because they have the same frequency, they'll have the same wavelength and period as well. But they're different, we can see, because they line up differently, and that lining up is phase. And phase is measured as an angle, and there's different ways to measure angle depending on your sort of mathematical background. We're most used to measuring angle in degrees, where there's 360 degrees in a circle. Mathematicians sometimes use radians, where there's 2 pi radians in a circle. If that's not something you're familiar with, don't worry about that. It doesn't matter. It's that it's angle and it's connected with a circle. But the question, the very natural question to ask is, what does this have to do with the circle? What does that have to do with the circle? And it's a good question. And there's, as usual, a beautiful and elegant mathematical answer that involves the unit circle and what a sine wave is. What does the sine function actually read? I encourage you to go and check that out. I'm linking another video that specifically sort of outlines this, and certainly look up the unit circle and learn as much as you can bear about that if you haven't already, because it's actually, there's some really beautiful math there, and actually a good explanation for why it's 2 pi radians, why that's preferred by mathematicians over 360 degrees. That's not necessary for this, but it is great for your general education. Anyway, I do want to use an example circle here just to illustrate how we get a sine wave. Now, this is basically circular, and let's have a look at this reflector as it goes around. Oops, I want to make sure that stays straight. Okay, so we've got that going straight, and I'm going to just get it spinning. So you see it's going up and down, kind of like a sine wave. And in fact, as it goes up and it comes down, it's going up, and it hits a peak, and then it comes down. It's moving fastest right here, and its upward downward motion is slowest at the bottom of the top. So it does that. And if you were measuring that movement over time, what you get is a sine wave, where it slows down near the top, then it comes down, it slows down, it comes up. That's basically where we get the sine wave. There's some fun math stuff that happens. Like I say, the video linked in the description shows it a little bit more explicitly and clearly than I can with the bicycle in my clutter office. But that's the basic idea. That's why we use degrees. You can think of, a sine wave as a cyclical thing, right? It goes, it cycles, and then it does the same thing again. Same way as a circle. You go around it once, and then you just do the same thing again. So there are some geometric connections there that aren't too out there. They're not too esoteric as mathematical concepts. And so you can imagine when you're dealing with waves like this, these ones are out by, it's a quarter of a cycle, so that would be 90 degrees. 180 degrees, they'd be exactly opposite. 260, they'd be over here, and, sorry, 270. And then 360, they would actually be, the one wave would have gone so far out of sync with the other that it's lined up with the next cycle. So they'd be together again. Just like if you get one whole lap around the circle ahead of your buddy, you're back at the same place, right? So a lot of really nice parallels between circles and sine waves there. We rarely actually have to deal with phase in the day-to-day work of phonetics. They are behind the scenes in some of the advanced techniques that we're going to be looking at from a surface level in upcoming videos, upcoming sections. And if you want to be part of the ongoing work on refining those techniques, then you do have to understand where phase comes into the mathematics. But for most of what we do, for the rest of what we do in this course, you just have to know that it's a property, and two waves that are otherwise identical but have different phases are going to be out of sync with one another in this way. Okay, so that's it for phase, and that'll close off the acoustic properties section. Be another video just sort of tying it all together, and there you go.